didn't ask me about this task. Yeah, here we said it's done by virtual physiological experiment, so it's virtual, so it should be done by some program. And I said that program's name is luprafism, and here it is. Its name is um, yeah, here. This is lesson number 1. We have lesson number 2. We have virtual physiology. You can download it from here, and I download it, but it cannot run on my computer, so I just upload it on my Google Drive here, and I upload it on my Google Drive, and then I use this program to open it, and I opened it, and this is our experiment to do. And again, here, and I choose this one because this is the task we should do. And here's the excitable threshold, represents blah blah blah, everything. You can read it, and you can techniques. Again, here we have next practical session, and we should open the stimulator, and we should open the amplifier. And again, then here we have a nerve fiber. I think it may nerve fiber, yeah, the clear screen. And here you have intensity of stimulus, kind of strength of stimulus. And again, here kind of first one, impact of stimulus. Maybe this is translation error. It's strength of stimuli, strength of stimuli until the action of potential, until the action potential appear or generate. Yeah, until the action potential generate. Yeah, it's correct. So again, let's use it. And here I increase the stimuli 0.1. I give stimuli no action potential, and I increase to 1, no action potential, 1.1 no, 1.2 no. Yeah, I increased. Yeah, maybe we have action potential at some point. Yeah, here 3. And again, I want to determine the threshold. 8, 2.7 no action potential, 2.8 no action potential. This is electrical stimuli. And 2.9 no action potential, and 3 microvolt we get action potential. So it means this 3 microvolt is excitable threshold. So here you can write answer 3. And again, number of stimuli. Yeah, number of stimuli. Here it is, number of stimuli is 1, and we give strength of stimulus, it's 3 microvolt, and we just stimulate once, and we get action potential. So here number of stimuli is 1, kind of response action potential. Yeah, we get it, kind of positive. Yeah, we get it, we get the action potential. Then next one is, so here we determine the threshold of this excitable tissue. Its threshold is 3 microvolt. Then we used several threshold, it's sub-threshold stimuli with high frequency. Let's do it again. Here I clear the screen, and I use 2.9 stimuli, no answer, and I increase the frequency 2, no, increase to 3, yeah, until we get, I increased it to 4, and I get action potential. So here I should try 2.9, and the stimuli number is how much is it? Yeah, 4. Yeah, 4, and I get result. Yeah, I get action potential. And then I will use maybe some sub-threshold, maybe 2.7, and clear the screen with frequency of stimulus 1, no, and I will increase to 4. Yeah, I get results. What about if I increase to 3? No results. Yeah, I get results. And again, I decrease this one to 2.5, and no answer, no answer. Yeah, I get the answer, and I must know, is it number 4? No. 5? No. 6? Yeah, I get the action button. So here I write, if I use the strength of subthreshold stimuli with 2.5 microvolt, and I get action potential after frequency of using frequency of 6, and I get result. So conclusion, it's you have right. First, yeah, first we determine the threshold level of this, yeah, excitable tissue, um, a and which that, yeah, the threshold is equal to 3 microvolt. Yeah, 3 microvolt. So it means the stimuli which below this level will not generate action potential on this tissue, you know. But sometimes we can get action potential even if the strength of stimuli below subthreshold level. How? We will increase the frequency of stimuli. This uh, this one we call it summation. Yeah, we get summation even if the threshold strength, even if the stimuli strength is below threshold level, we can get action potential only via increasing the frequency of stimuli. Yeah, so here it said it blah 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 something, and application of several subthreshold stimuli with high frequency can determine the presence of an action potential, and as a result of their cumulative action, it's called temporal summation. So that's all.